Let's try this question. Okay. So, to understand position vectors. So, in a trapezium PQRS, we have PS is parallel to QR. So, they are saying PS is parallel to QR and PS equals to 2 times of QR. So, PS is equals to 2 times of QR. Point M lies on PS such that PM is to MS is equals to 1 is to 1. Huh. Then that means PM is equals to MS. And since it is breaking PS into two, so we have PS something like that. Let's say PS looks like this. And they are saying 1 is to 1. Okay, so PM is in the middle. So PM is equals to MS. We can say PS is equals to 2PM. Or we can say 2MS. Can't be? Yeah. So we can. So I'll also write that down. Okay. So PM is equals to MS and PS will be equals to 2PM. Or we can say 2MS. And since PS is equals to 2QR, we can also say this is also equals to QR. Well, that's good. If the position vectors of P and S are vector P and vector S respectively. So they're saying OP is equals to P and OS is equals to S. That's what they're saying. Okay. OS is equals to S. And they are asking us to find OM, the position vector of M. So we have to find out OM. Let's say OM is equals to M. Now we have to do this. Okay, fine. First of all, let's draw this trapezium. Okay, let's draw this trapezium. Okay, we'll draw the trapezium PQRS first of all. It should look like this. If I take this as QR, PS should be something like this. It should be parallel and double the size. So it should look like this. Yeah, close enough. Yeah. So you don't have to exactly be perfect with your drawings. Okay, you can make mistakes, but try to be at least a little bit appropriate to that. Okay, so PS is parallel to QR, PS is equals to 2QR, and PM is equals to MS. Okay, and yeah, they are saying OP is equals to P vector. So let's say O is here, somewhere here. Okay, so now we know. Okay, now we know OP is equals to the P vector. Okay, OP is the P vector. And then we have OS. Okay, we have OQ. No, OS. So I have OS, which is the S vector. Which is the S vector. And I have to find out OM. That's the question here. Okay, I have to find out OM. That's the question here. Okay, fine. How can I go to OM? Well, OP plus PM is equals to OM. But OM is equals to OP plus PM. Okay, and I know PM is equals to MS, and that is also equals to half PS, right? Yeah, I can say half PS. How? So here I have PM. Okay, so 2PM is equals to PS. So I can say PM is equals to half PS. I can say that. I can. So that will be half PS. So that is equals to half PS. So how to find out PS? PS is equals to PO plus OS. That's it. Now we can find the answer. So PS is equals to PO plus OS. We know PO is equals to minus P. So minus OP plus OS. So minus OP is equals to minus P plus OS is equals to S. Here we know PM is equals to half PS. So I can say half minus P plus S. And here we have OP plus PM. OP is equals to P. And here we have minus half P plus half S. Okay. Why? OP is equals to P. PM is equals to half minus half P plus half S. So this will be equals to half P plus half S. Okay. So OM is equals to half P plus half S, which can be written down as half P plus S. That's it. That's it. That is OM. So we can say M is equals to, this is what we had to find, half P plus S. So you should be able to change the letters and play with the letters, okay, when you're doing vector questions. I don't know why they gave QR. Okay, I don't know why they gave QR. Okay, I really don't know. If they asked QR, okay, if they had asked QR, if they had asked us to find QR, then we can say that is equals to PM. Why? We know it doesn't matter which because we know QR is parallel to PM, so we can say QR is equals to PM. That's the vector idea. I told you, right? In a two-dimensional plane, wherever you draw the vector, it doesn't matter. Okay, it doesn't matter. But when it comes to position vector only, okay, you have to think about from a point. Think of it as at from a point. Okay, so keep that in mind. Okay, that's it. So this is the first question. I think you are also able to do this. Now let's go to the second question. We'll do another question. So in this question, they're asking in a trapezium PQRS, PS is parallel to QR. Okay, it looks like the previous question. So they are saying PS is parallel to QR, and they are saying PS is equals to 3 times the QR, and they are saying vector PQ and PS are vector Q. This is different because they are not speaking about the position. PQ is equals to vector Q, and they are saying PS is equals to vector S. Okay. Point N lies on QR. Okay, so if this is QR, okay, if this is QR, it lies in 2 is to 3. So this is N. If this is 2x, this will be equals to 3x. That's what they are saying. Or you can say, since Qn is to Nr is equals to 2 is to 3, you can say Qn over 2 is equals to Nr over 3. So this is 3Qn is equals to 2Nr. Okay. So you can also write like that. 3Qn is equals to 2Nr. But the thing is, this is 2 over 5. Qn is equals to 2 over 5 of Qr. Do you agree with me? Here we have 5x. If this is 2x and this is 3x, we can say Qr is equals to 5x. Okay. So, and we know Qn is equals to 2x. Okay, so I can say QR over Qn is equals to 5 over 2. So I can say Qn is equals to, I'll bring 2 here and 5 here. So it will be 2 over 5 QR. That is also we can say. Okay, so we can say Qn is equals to 2 over 5 QR. Similarly, we can say Nr is equals to 3 over 5 QR. Okay. They have asked us to find the vector ns. We have to find the vector ns. That's the question in terms of q and r. Shall we do that? Yeah, let's do that. Okay, first of all, we have to draw a diagram, or else it's a little bit hard to actually put down the letters, okay? So the vectors to find the answer. Okay, so let's draw a diagram. So this looks like this. It look like this. Yeah? 1, 2, 3. Okay, and we can connect these points. Okay, this is also can be connected. So we have PQRS. So PQRS. And they're saying PS is parallel to QR. Perfect. That's what I drew for. PS is equals to 3QR. That is also done. Okay. PQ is equals to Q. Okay. PQ is equals to Q. PS is equals to S. Okay. And they are saying 3QN is equals to 2NR. Oh, so it's somewhere here. Yeah. N is somewhere here. Okay. Qn is equals to, that's all fine. We have to find out ns. Okay, the question asks us to find ns, which is this. Okay, but we can't directly find ns. We can't. Why? We don't. We know nr, but we don't know rs. Okay, we don't know rs, so we can't directly find that. So what about? What if we found out pn first? Okay, what if we found out pn first? If we found out Pn, we can say Np plus Ps is equals to Ns. Okay, but we know Pn can be found. Why? Pq plus Qn is easy. Okay, so let's start with. So we know Pq is equals to Q, and now we have to find out Qn, and we know Qn is equals to 2 over 5 2 over 5 QR. But the thing is, we know QR is parallel to PS. Okay, and that 3QR is equals to PS. Okay, so we can write, since PS is equals to 3QR, we can say QR is equals to QR is equals to 1 over 3 PS. So this will be equals to 2 over 5 into, well, not into, okay, multiplied by 1 over 3 PS. Okay, so that is 2 over 15 PS. And we know PS is equals to S. That's what we already know. So Qn is equals to 2 over 15 S. So we need to find Pn. So Pn is equals to PQ plus Qn. So PQ is equals to, what's PQ equals to? Q. And what does Qn equals to? 2 over 15 S. So now we know Pn. Okay, now we know Pn. Now we just have to find out Ns. So we know Ns is equals to Np plus Ps, and we know Np is negative of Pn, and we can write out Ps. So that's it. So Ns is equals to negative Pn, which is negative Q, negative 2 over 15 S plus S. So that will be equals to, what do we have? Negative Q plus 13 over 15 S. Or you can write this down as 1 over 15, okay, 13S minus 15Q. Okay, you can see here I'm not writing 13S over 15. I could have written like that, but I'm not doing that because we should show the difference between the vector variable and the normal variable that we are using. Okay, the scalar variable that we are using. So that's why I'm not writing them down like that. Okay, so these are some questions that you can practice. Okay, and let's try another one. Yeah, let's try another one in the next video.
Thanks for watching the fourth video in our vector series. If you found these position vector practice questions helpful, don't forget to like, share, and subscribe for more tutorials. Hit the bell icon to stay updated with our latest videos. Check out the full playlist to master vectors. I'll see you in the next video. Until then, keep learning and stay curious. Bye bye.